So welcome to day 3 of quadratics. And we're going to start off with sort of a simple review of the box method, which, as you hopefully remember, is how we learn to factor quadratic equations. So what will happen is problems will start with an equation in standard form. So it'll look like this. If it's not in standard form, you have to try to get it into standard form. And so once you have an equation like this, you would find A, B, and C. So A, B, and C. And then you write ax squared into the top left box. So in an actual equation, A would be a number. And then, sorry, let me just let someone else in right now. Okay, and then you would put C into the bottom right box. Now it gets a little bit more complicated. So we have to multiply A times C and then find the factors of whatever we get after we multiplied. We have to find factors of that sum to B. And then we would put those factors into these two remaining boxes. Then after that, we would find the greatest common factor of these top two and write it right here. Find the greatest common factor of this second row, write it right here. Same thing for the columns. And then you would make sure the negatives are correct, and then you have your factored answer. So this is of course, kind of abstract, and we're going to do an example with an actual equation after I let someone else in. Okay. So here's our example problem, x squared plus 2x minus 15. And you can see that this is already in standard form. You have ax squared plus bx plus c. And of course, a here is just a 1 that's not written. So
x squared goes in the top left box.
Yeah, exactly. And then what's the next step after that?
The negative 15 goes in the bottom right.
Yep, remember on the previous slide, we put C in this bottom right box. Okay, next step, multiply A times C. So what would that be?
15. Negative 15.
Yes, perfect. You got to be careful about that, but good job. Okay, so A times C is negative 15. And now we have to find two factors of negative 15 that sum to B, which is 2. So
negative 3 and 5.
Negative 3 and 5. Yes, that would work. Good job. So negative 3 times 5 adds up, negative 3 times 5 equals negative 15. And they also add up to equal 2, which is B. So those are the two numbers that are going to work. And now we're going to write them into the remaining boxes with an X on the end. And it doesn't matter which box you do it. So you could write negative 3 in this one, and then 5x, negative 3x in this one, 5x in the other one. That doesn't really matter. Okay, let me let Rishikesh in. Okay, now does anyone besides Anikit, because you've already participated a lot, does anyone remember what the next step should be? You can type it in the chat or say it out loud.
You find the GCF of 5x and x squared.
Yeah, we find the greatest common factor of the rows and columns. So we're going to do this column first, x squared and 5x. The greatest common factor of that would be anyone?
X.
Yeah, good job. It would be x. And then same thing for this other column over here. What is the greatest common factor of negative 3x and negative 15?
Negative 3?
Yeah, good job. And just to check yourself, if this number is right next, the box right next to it has a negative, then this number will also be negative. So this negative 3x is next to this negative 3, just to check yourself. Okay, and now we're going to do the same thing, but for the rows. So let's take the top row, x squared and negative 3x. What's the greatest common factor?
X.
Yep. And this one is not going to be negative because the box it's next to is just x squared, which is positive. Okay, and now the greatest common factor of 5x and negative 15.
5.
5.
Yep, good job, guys. And so now we have our factors. So right here and right here. And so this would be a plus right here. So, oops. So our answer would be x plus 5, the quantity of that, times the quantity of x minus 3. And so that's just our original equation, but written in a different form. All right, does anyone have any questions? Okay, you joined late, so you don't really know what to do. Were you here last week when we explained the box method? Okay. So this is not really that relevant to most of what we're going to cover today. We're mostly going to talk about the quadratic equation. So that's okay. If you want to learn about the box method, there are some really great YouTube videos. You can just search up the box method for factoring quadratics, and you can watch the recording and look at the slides from last week. Yeah, good. Okay. So let's clear this. And like I said, we're going to be doing the quadratic equation. So last week we did a little bit of practice with using it to factor equations. And today we're just going to learn some other really helpful tricks you can do. So the quadratic equation is just this really complicated formula you see here, but you can use it to factor any quadratic. So you take a quadratic in standard form, which is I'll write it again, ax squared plus bx plus c. And then you can use the quadratic equation to factor it down into smaller parts that multiply together. And so, does anyone remember the song that we use? Because this is obviously going to be a really long formula, but there are ways you can memorize it. Does anyone remember the song we learned last week?
No.
All right. I'll show it because why not? It's basically to the tune of Pop Goes the Weasel, if you know that. Let's see. And this is just going to help you remember.
The quadratic formula's negative b plus or minus the square root of b squared minus 4ac all over 2a.
See, it's as simple as that.
Can you post the link in the chat? Because I don't think I really got the entire thing.
Yeah, sure. I'll put the link.
Take chapter and thing you don't want.
I don't think I'm in the right class.
Oh wait, who said that?
I'm not in the right class.
Hmm.
Okay.
Can you say your name?
Because the other people aren't here.
Okay, wait. Who? Okay, I'll move you.
Okay.
Hang on one second.
Wait, which one was it here?
All right, so you can go back to the main session. Okay, and then I put the link to the video in the chat, so you feel free to play it for yourself.
Not a class.
But in any case, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac and everything over 2a. So what you would just do is when you have it in standard form, you just plug in the values for a, b, and c, and then you get the roots of the quadratic, or basically where it touches the x-axis. Now, disregarding the whole quadratic equation, you can just look at a part of it. So the value underneath the square root, but not including the square root, is called the discriminant, and that's b squared minus 4ac. So there are some interesting tricks you can use with the discriminant. If the discriminant is negative, then that means the quadratic has no real roots. So if you do b squared minus 4ac and you get a negative number, then that means the quadratic does not touch the x-axis, and there's no real roots. So you're not going to be able to find an answer to it unless you know imaginary numbers, which I'm guessing you guys probably don't, but don't worry about that. Now, if the discriminant equals 0, that means b squared minus 4ac equals 0, there's going to be one real root. So the quadratic will just touch the x-axis at one point. And I'm going to show you guys some examples on a graph in a second. Then the third case is if the discriminant is positive. And that means there's going to be two real roots. So let's take a look at some different equations. We'll start off with this first one, negative x squared minus 1. So this is an example of something that has 0 real roots. As you can see, it never touches the x-axis, and so it's not going to have any roots. If something touches, the point at which the graph touches the x-axis is called its root. And so if you did the discriminant on this one, you would get a negative number. So this would just be like, imagine b to be a 0. So the full form of this equation would be negative x squared plus 0x minus 1. And the discriminant is b squared minus 4ac. So b squared is 0 minus 4 times a is negative 1 and c is also negative 1. So now it becomes 0 minus 4 times 1, because negative 1 times negative 1 is 1. 0 minus negative 4. Oh, sorry. 0 minus 4. 0 minus 4, negative 4. So the discriminant is negative 4. And like you saw in the slides, if the discriminant is negative, then there's going to be 0 real roots. 0 points where the graph touches the x-axis. And if you have any questions at any point, just stop me, type something in the chat.
I'm totally.
Okay.
So in the formula, it says B, A, and C, right?
Yeah, the formula is b squared minus, sorry about that, b squared minus
Yeah.
4ac.
Yeah, I get that. So it's the variables are B, A, and C, right? So
Yeah.
what is the B and what is the A and what is the C?
Okay, so remember this standard form that we've been using?
Yeah.
So you would just, if when you're given an actual equation, A, B, and C are going to be different numbers, and you would just take the A, the B, and the C, and then you would put them into this, the discriminant.
Oh.
Yeah, so if you remember the box method, you put C in the bottom right corner.
Yeah.
That's basically the same thing. You just take whatever value it is and put them, plug them into this equation.
Okay. Thank you.
Yeah, thanks for asking. And so what you get after you put them into the equation b squared minus 4ac basically tells you what the graph is going to look like. So if we take a look at this one would also have a negative discriminant, and it's not going to touch the x-axis, so it doesn't have any real roots. This one, the discriminant would equal 0, and that means there's going to be one root at -5. So you can see it just touches the x-axis and only at one point. And this one is going to be easier to do the discriminant on, so let's give it a try. So quickly in the chat or out loud, who remembers what the formula for the discriminant is?
I do.
All right, you can say it.
Negative B plus or minus square root
Oh,
of
wait. That's the whole quadratic formula. The discriminant is just part of the quadratic formula.
negative B times plus 4ac.
Yeah, that's really, really close. Just it's positive. Wait, it's going to be b squared minus 4ac.
Okay.
So if you, I think you remember the whole quadratic formula. The discriminant is just the part that's underneath the square root. So b squared minus 4ac, sorry, I forgot the c. And so we're going to do that on this equation. So remember the a is just this hidden one. 1 is a, 10 is b, and 25 is c. So b squared is going to be 100. And then minus 4 times 1 times 25. So that's going to be 100 minus 100. And the discriminant is going to be 0, like I said before. So that tells you the graph only touches the x-axis at one point. Okay, so this next one is an example where the discriminant is actually a positive number. So that tells you that this is going to have two roots, and it does, -3 and 5. So if you did b squared minus 4ac on this equation, you would get a positive number. We're not going to do it right now. And this is something I would just write down really quick. So write down negative discriminant equals no roots, 0, discriminant equals 0, 1 real root. Positive discriminant is 2 real roots. Yeah, go. And then we'll also write down b squared minus 4ac is the discriminant.
Can you only have two roots on a line? Can you not have more than that?
Oh, that's a good question. So for a quadratic, it can only have a maximum of 2 roots, but you can find some other equations. like cubic equations that have 3 roots. Basically, you look at the largest exponent, quadratics, the largest exponent is a 2, so it can only have a maximum of 2 roots. But if, like, say the largest exponent is a 3, hang on. Okay, wait. Let's make a cubic function real quick. This is in factored form. So you can see here there's going to be 3 roots at 1, at 2, and at 5.
Okay, cool.
And you can like add more. This would be a quartic function. So it has 4 roots.
Wow. Okay. So those are not quadratics, right?
Yeah, these are not quadratics. Quadratics are where the largest exponent is a 2.
But
so
then
they're-
how come it says quad in radix, in the quadratic? Doesn't quad mean 4?
Yeah, that's just a weird thing. I guess you can think of it like the largest term is x squared, and the square has 4 corners.
Okay.
Yeah,
That's-
it's just kind of funny. You have to remember that.
Okay.
So let's do some practice with discriminants. All right, so this first equation actually is not in standard form, so we have to get it there. And what we're going to do is subtract 7 from both sides. So x squared minus 2x minus 9 equals 0. And now it's in standard form. So you can do, remember the discriminant, b squared minus 4ac. And using that, I'll give you guys a while, 2 minutes, to find the discriminant. For what you missed, I was just talking about some cases where there can be more than 2 roots that aren't, for equations that aren't quadratics. So go ahead, give this an attempt and try and find what the discriminant is. So AKA what b squared minus 4ac equals for number 1.
I figured it out.
All right, hold your answer until like 3:32. All right, so everyone who got the answer, go ahead and put it in the chat. Even if it's just a guess. Okay, Aniket says no real roots. So let's see. Remember, so -2 is going to be b here, -9 c, and a is going to be a hidden 1. So b squared minus 4ac, b squared is -2 squared, which equals 4. Minus 4ac is going to be minus 4 times 1 times -9. So that would be 4 minus -36. And 2 negatives make it positive. So that'd be 4 plus 36. So the discriminant equals 40. If I haven't done it something wrong. So since it's positive, I think that actually means there's going to be 2 roots. Oh wait. Okay, I think I did do something wrong. Okay, minus 4ac. you've got to be careful with the negatives. Let's see, wait. B squared is going to be 4 minus 4 times A times C. Okay, wait, Aniket, how did you get no real roots?
I kind of guessed.
Okay. I think the answer on the slide. Let's see. We'll take a look at it in Desmos. So x squared minus 2x minus 9. Yeah, so this one looks like it actually has 2 real roots. You can see that it crosses the x-axis at those 2 points. So I think the answer on the slide is wrong. Sorry about that. So this one should be 2 real solutions. Okay, we're going to do one more. And remember, this one has to go into standard form first.
I got my answer.
Okay. I'm going to ask you to explain the math behind it. Okay, do you think you can do that?
No, not at all.
Then how'd you get your answer?
It's just guessing.
Okay, well, maybe it's better not to guess.
Maybe.
Maybe. All right, so
I mean, better points than no points. So you miss 50% of the shots that you don't take. Wait, no, you miss 100% of the shots you don't take.
yes, sure. Okay, but it would really be ideal if we could do the math. So we're going to put this into standard form by adding 6 to both sides. So this becomes a 35 once you add 6, and then this side becomes 0. And now, can anyone tell me what A, B, and C are in this equation that I've written?
I can.
All right, go ahead.
So A is -2, B is +9, and C is 29.
Okay, remember, we're doing the one in standard form. So you got everything right, but C.
Just 35.
Yeah, 35. So
Okay, yeah, because you had to add the 6.
yeah.
Yeah.
So B equals 9, C equals 35. Okay, now you know all of the variables. So you just have to plug them in to this problem right here.
So it'll become 81 minus minus
4AC. So
so
that'll
that'd
be
be
4 times.
280 minus 280.
Okay, yeah. Wait, hang on. We're just gonna take it slower. So 4 times A, which is -2, times C, which is 35. Are you sure it's 180? 4 times 2 times 35. Oh, 280. Okay. Did you say 280 or 180?
I said 280.
Okay, sorry, I misheard then. Okay, so remember this is a -2, and then
Okay, so
it
that
would be-
becomes positive.
yeah. So it would be 280, 81 minus -280. So it becomes just a positive 81 plus 280. All right, so now we have a positive discriminant because the answer is just going to be 361 for the discriminant. So what does that tell us?
Positive discriminant.
Yeah, and what does the positive discriminant tell us?
2 real roots.
Yeah, this answer is correct this time. So there's going to be 2 real roots, and the graph will intersect the x-axis at 2 different points. So a way you could use this is like, say the question just gives you this equation and you have to match it. Say that it has like 4 different graphs and it asks you like which one of the graphs matches this equation. You might be able to use the discriminant and see, oh, this graph passes through the x-axis twice, and the discriminant is positive, so therefore that's the right answer. All right, we're gonna skip past the other two for now. So as a summary for the quadratic equation, if you're given an equation in the form ax squared plus bx plus c, the roots of it would just be like that. All right, so this basically involves using the full quadratic formula to find the roots. So we're going to use this whole thing, not just the discriminant, we're going to use the whole thing. And we're going to use it to solve some problems. So I'll write it out for you, although remember, you should try to memorize it. All right, and then for problem 1, who can tell me what a is? Anyone?
1.
Yeah, good job. So a equals 1. And what about b?
Negative 14.
Good job. And then c?
Negative 32.
Yeah,
That's good.
exactly. Good work. And so now what you have to do is you have to plug these numbers into this equation up here. So basically everywhere there's an a, put an a, everywhere there's put 1, everywhere there's a b, put negative 14. Then you have to do all the math and solve it. All right, so I'll give you guys 4 minutes for that. And that's the thing with the quadratic formula. It takes a while to do. So if you know other methods of factoring, you can do the problem faster. But right now, we're just going to practice it.
I got my answer, but I don't know if I should plus or minus. How do I calculate that?
Okay, so actually it's going to be both. So this one is going to have 2 answers. And so one of them is going to be where you use the plus, one of them is going to be where you use the minus.
I got the answers.
All right, what did you get?
I got 169 and negative 155.
Okay. That seems a little bit odd. I think some part of your math might have gotten a little bit wonky.
Okay, I'll recheck.
Okay, yeah, good idea. Okay, and when you get an answer, you can go ahead and put it in the chat.
Could I share my answer?
Sure.
So is one of the answers 175?
No, but I'm glad you tried. So how about we go through it? So the actual answers are -2 and 16. I think it's really easy to mess up on this long quadratic formula. So let's see, -b is -14, so -b is going to be 14. Remember, it's going to plug everything in one by one. Then under the square root, we have b squared minus 4ac. So -14 squared is 196. Minus 4ac, so 4 times 1 times -32, because those are the values for a and c. Then everything over 2a. So a equals 1, so 2a is going to be 2. All right, now I have to do the math, and you have to be very careful not to mess up the negatives. So 196 minus 4 times 1 times -32. That would be equal to, so equals, I'm going to write the whole thing.
मैं क्लास कर रहा हूँ मम्मा, आप करो प्लीज.
196 minus 128. And 196 minus 128 just equals 68. Oh, wait. Wait, that seems like it might be off. Okay, everything over 2. 4 times a times c.
Oh.
I accidentally made the minus a plus. That's where it went wrong.
Okay. So yeah, this equation thing is probably not the most efficient way to solve it, because this one is actually something you can use the box method on. And I think that would be easier.
Wait,
'Cause-
I got a question.
yeah,
You wrote that it's 4 times 1 times -32, right?
yeah,
Wouldn't that be -28, 128?
right. Oh, okay.
And then the two negatives would cancel to a
Yeah,
positive.
yeah. So that's the mistake. Thank you for that. So we've got to be careful about our negatives. So 196 plus 128, and that gets you 324. Okay, so that makes a lot more sense. Now, the square root of 324 is 18. So we have 14 plus or minus 18 and everything divided by 2. So we can go ahead and divide everything by 2 first. So that would just be 7 plus or minus 9. And now what do we do with the plus or minus? So that means it's going to be either 7 plus 9, that's going to be one of the roots, and the other root is going to be 7 minus 9. So that's,
That's 16 and -2.
yeah, so that's how we get 16 and -2.
Okay.
So this works, it just takes a long time, and it's easy to mess up your negatives like we did. So this would be something probably better to use the box method on. But it is also really good to know the quadratic equation. So we're going to do a bit more practice.
Joe Biden.
Okay, so next problem, x squared plus 2x minus 46 equals 2. So we're going to get this in standard form first by subtracting 2 from both sides. And then it's going to become, when you subtract 2 from both sides, x squared minus 2x minus, I'm sorry, x squared plus 2x minus 48 equals 0. So disregard this one. And now we have to do the quadratic equation. So go ahead and try that. I'll write the quadratic equation for you.
Zero में आया मम्मा.
All right, I'll give you guys some time. And then when you think you have an answer, go ahead and put it in the chat. Can you repeat that if you said something? Okay, I think you're cutting out a bit, so can you type your question in the chat? Sorry about that.
Is the answer 6 and -8?
Let's, so, okay, so let me just, x minus 8. Oh, sorry. Yeah, you guys are correct. So let's take a look at doing this. So b is 2, negative b is -2. Yeah, that's a 0. You can disregard that. So -2 plus or minus square root of b squared. B squared is 4 minus 4 times a is 1 here, times c. C is -48. And everything is over 2a. So since a equals 1, 2a is going to be 2. That was a very long line. And so now we have to simplify further. So -2 plus or minus the square root of, so 4 times 1 times -48. What does that equal? That would be negative.
196. Negative 196.
Okay, so the whole thing. Wait,
Or
-48 would be 100, -192.
yeah, but then when you add that with 4, it will become 196.
Okay, wait, but remember this negative. It should cancel out and become positive.
Yeah, that's what I'm saying. Like you had to do
Oh,
4
right.
minus 92.
Yeah, okay, you're saying, I think you said -196, which threw me off.
No, it's positive.
It should be positive 196, you're right, so. So we have that once we do the parentheses, and then now we're going to do 4 plus 192, which is 196. All over 2. And now square root of 196 is 14. I'm going to do it down here. -2 plus or minus 14 over 2. And then divide the 2. So that'd be -1 plus or minus 7. And then that branches out into 2 possibilities for the root. So it could be -1 plus 7 or -1 minus 7. So that's how you guys got your answers. So good job. Hopefully you guys are getting how to use the quadratic formula. Right, so let's move on from this. Okay, we can skip past this too. This is an example of using the quadratic formula. Oh, this is the same thing we just did. Okay, on to something new, which is the difference of squares. So this is just an interesting pattern. If you're given a problem that's just a squared minus b squared, that actually equals a minus b times a plus b. So if you have this memorized, you can automatically know how to factor this. And let's just examine why this works, okay? Because what happens is like some of the terms will just cancel out. Now, this is going to be a big throwback, but we're going to use the FOIL method. So that means we're going to multiply this term, these terms, and
Does FOIL stand for like first outside, inside last?
it does. So the first ones in the parentheses are the 2 a's, last ones -b, and b outside is this one, a times b, and then inside is -b times a. So that just tells you what to multiply. Now, if you do that, you get this. All right, does anyone see what happens now in this equation?
That's just technically a square plus b square.
That's exactly right. So these two will cancel out because it's plus ab minus ab. And you're just left with a squared plus b squared. So that's why this pattern works. Oh, sorry. That's why a squared plus minus b squared equals a minus b times a plus b. All right, does anyone have questions at this point?
I do. But it says that a square minus b square technically equals a square plus b square.
Oh,
come
oops.
Something minus
Alright.
something equals something plus something.
Sorry, I messed this up. So remember when we multiplied negative b times positive b, that actually equals negative b squared. Yeah, sorry.
So like the problem would already be in factored form.
And also, when you multiply this negative b times this b, it's going to remain negative because negative times positive is negative. So that's why you get the minus.
Yeah.
Yeah. So sorry about that. That's just an error on my part. Okay. And now this is going to let you solve some types of problems just quicker now that you know this. So if you are given 4x squared minus 9, you know that 4x squared is 2x times 2x. So, and then negative 9 is negative 3 times positive 3. So you can put it into this pattern. Oh, and just to clarify, difference of squares. So that means that a squared minus, it has to be a squared minus b squared. So those have to be squares. Like both of these are squares. If they're not both squares, then you can't do this pattern. So let's try a word problem. The difference between the squares of two positive integers is 2009. What is the maximum possible difference between these two integers? So using this, we can set up this equation. Since the difference between the squares is 2009, we know that a squared minus b squared equals 2009. And that equals a minus b times a plus b. Okay, this example is a bit weird because it's harder than how these problems would normally be. So it includes some other stuff. So I'm going to think of my own example instead. So let's say I have two mystery numbers and we're going to call them x and y. Now, the sum of x and y is 50, and the difference, the absolute value of the difference between x and y is 2. Now, what is the difference between x squared and y squared? Or we can say x minus y equals 2, x plus y equals 50, and what is x squared minus y squared? So this is the same concept as what we just learned. It's just presented in a little bit of a different way. It's a bit of a challenge. Does anyone see how we can get the answer? Or what question mark equals? Without just like trying random numbers and seeing which ones work.
We could find the difference between 50 and 2.
I think you're on the right track. So let's take a look at this original one. So a squared minus.
I know it. X
Okay,
has
okay.
to be 26 and y has to be 24.
You're right. But also, we don't even need to know that to solve this problem, because we have x plus y right here, and we have x minus y right here. And remember up here where it says if you do a minus b times a plus b, you get a squared minus b squared. Well, this is the same thing, just like different variables, x plus y times x minus y. And since x plus y equals 50 and x minus y equals 2, we can just multiply them together. And that gets us this question mark, x squared minus y squared. So x squared minus y squared equals 100. And since you did say x equals 26 and y equals 24. So that's correct. And we can use that to just check that this works. So what is x squared minus y squared? 26 times 26 is, I believe, 676.
And 24 squared should be 576.
Yep. And so then the difference is going to be 100, like we got using 50 times 2.
That's such a cool cheat sheet from that question.
Yeah, it is, isn't it? Because you don't even need to try and figure out what x and y equals. You can just, if you know this difference of squares, you can just solve it really quickly. But that's why we're here, to just teach you how to use these sorts of tricks in competition math. Okay, what's next after this? I think we have some application problems for factoring.
Quick question, are we gonna do a Kahoot?
We have a Kahoot. It has some kind of hard factoring problems, I think, or just not really that hard, but they're probably, the time limit might be kind of low. So do you guys want to do the Kahoot? Or
Yeah.
I'll
Kahoot.
just test.
Kahoot?
Kahoot.
Okay.
If it's very low time based, I'll test my luck.
All right, let's do the Kahoot then.
Wait 1 second. I'll be back.
Okay. So, and just remember, if you don't know how to factor something using like a faster way, like the box method, you can always use the quadratic formula, which is up there. I think I forgot the 2. Okay. So let's do the Kahoot. I have to log in. Okay, I'll stop sharing for a second. Okay. So I will put the pin in the chat. Oh, interesting. And go ahead and join this Kahoot. So this is going to be reviewing some of our factoring stuff. Don't be intimidated. The questions, you can do them. I'm sure you guys can do them. And if not, I'll give you guys some hints.
The rap is weird. I surprisingly want to watch this video. It's hilarious part. Then time to be.
Mm. All right, we'll wait until 4:10. Is this song helpful for factoring?
Nope, not at all.
I think it's fun to listen to at least. Okay. So let's start it. Hopefully the time limit is okay. All right, 16x squared plus 4x. So what you have to do is take out the greatest common factor between 16x squared and 4x.
And what do we do with that?
So the greatest common factor, what is the greatest common factor here?
4.
Okay.
4x.
4x, yeah. So now you divide 16x squared by 4x. What do you have left?
4x.
Yep. And then what is 4x divided by 4x?
1.
Yep. So basically, it's going to be 4x times 4x plus 1.
Okay.
It's
Thank you.
basically like you just took 4x out. Yeah, just told you guys the answer. Woohoo. So for this, you can see if we multiply it back together, we get 16x squared plus 4x, because 4x times 4x is, sorry, ignore that, 16x squared. And then 4x times 1, using the distributive property, is just 4x. So factoring is all about just recognizing the greatest common factor, taking it out, and then doing some division. Okay, same concept here. Same greatest common factor, 2 actually. Okay, it kicked you out. You can use the pin that I put up there to join it in again. Okay, so it looks like almost all of you guys do remember how to do this. It's not letting you. Okay. What you can do is you can just type your answer in the chat, and I'll give you points if it's correct. So what you had to do here, you recognize that the greatest common factor is 4x, and then you did 24x squared divided by 4x, which is 6x. Then you did 4x divided by 4x, which is 1. And that's the answer. And you can check yourself by multiplying it back in. You'll get 24x squared plus 4x. All right, good job. 6x plus 12. All right, find the greatest common factor, take it out, and divide everything. Okay, so the greatest common factor here was the 6. Both of them can be divided by 6. And so once you do that, you're left with 6 times x plus 2. And if like factoring it yourself is a little bit confused. Oh wait, never mind, that doesn't work. Okay. So you can check yourself. 6 times x is 6x, 6 times 2 is 12. Okay, does anyone have questions? Because I know that was a little bit fast. All right. Nice job. Nice job. All right, factor 16x squared plus 8x. All right, just be careful. Remember, 4x is not the greatest common factor. There's one that's even bigger than that. Wow, all of you guys got it. All right, good work. So the greatest common factor here is 8x. And so if you take 8x out, then 16x squared divided by 8x, you're left with 2x. 8x minus 8x is plus 1. And obviously this one's not right because it has a negative, and there's no negative in the start. Good job. Ooh. Okay, so this one gets harder. The greatest common factor here is 5x squared. So you have to take 5x squared out and then divide each of the terms by 5x squared. But I think you can do it if you just think about it. It is blue. Okay, so I guess I kind of told you to take out the 5x squared, but you can see that if you multiply everything back in, 5x squared times 4x squared equals 20x cubed. Because remember, x squared times x squared equals x cubed, and you just add the powers. Plus 5x squared times 3x, which is 15x cubed, and plus 2. Oh, sorry, plus 5x squared times 2, which would be 10x squared. And that's the original one. So this would be the correct answer. Okay, so this is one you could use the quadratic equation or the box method on, because this is a quadratic finally. Or you could just look at the answers and multiply them out using the FOIL method to see which of them turn back into that equation. There's a lot of
how do you
different
find the answer basically?
All right. I wish there's a way to pause it. Okay. So box method, quadratic equation, or just multiplying it. So let's do box method. So what goes in this top left corner? Let's do the box method on this one. The answer is blue. So I guess 3 of you got it. Nice. So x squared goes in this corner, 7 goes right here. And now we do a times c. A is 1, so a times c is 7. And we have to find factors of 7 that add up to 8. So does anyone know what factors those would be?
7 and 1.
Yeah. Okay, wait, you can't unmute. Oh, let me see if I can unmute you. This might be a bit buggy. Yeah, so 7 and 1. So those are factors of 7 that add up to 8.
Yeah, so 7 and okay, yeah. So then those factors add up to 8, and then so like that would be x plus 7 in parentheses, and then x plus 1. Okay, yeah.
Yeah,
I
yeah,
get
yeah.
it.
All right. So then you would just write them into the mixing boxes, find the greatest common factors. And now you have the factored form. And once you've got more experience, you can kind of ditch the box method. It's just a helpful thing for when you're starting out to learn, when you're just starting to learn this. But when you have years of experience, you can just basically look at this problem and kind of instantly know how to factor it into this. You just know that the last numbers have to multiply to 7, and then they have to add up to 8. The box method is just an easy way to visualize how this works. Okay, good job, you guys. X squared plus x minus 90. So same thing as last time. I think there's a lot of ways you can try to do this one from. That picture thing in the center is really interesting. Just slowly revealing the giraffe with his head in the ceiling holding up the chandelier. Right, so the correct answer here is yellow. And I can see why you guys thought blue, and that's a really easy mistake to make. So we're going to try solving this one using the FOIL method to just check the answers and see which one works. So for blue, we do x times x, which is x squared, plus x times negative 10, which is negative 10x. And then the plus and the minus turn into just a minus. Now we do 9 times x, so that's plus, oh, that's a horrible plus 9x. And then finally 9 times negative 10, minus 90. Okay, and then the two terms in the center, you can combine them. So negative 10x plus 9x is negative x minus 90. All right, so now this blue square, it equals x squared minus x minus 90. But is that the same as what the question is asking for? I don't think so, right? Because the question is asking for x factoring x squared plus x minus 90. So this one is actually not correct, but it looks like it could be correct. And if you multiply out the yellow option, you'll see that you will get x squared plus x minus 90. And again, you can also use the quadratic formula or the box method for this one. Okay, let's do one more. X squared, factor x squared plus 2x minus 24. All right, x squared plus 2x minus 24. So again, you guys, it looks like this one, these two answers are really similar, but the middle term is just going to be wrong on the blue one. So an even faster way to check this than the FOIL method is just to go -6 times 4 is -24. So that's correct, but -6 plus 4 is -2. So if you do the FOIL method, that would end up as -2x in the center instead of plus 2x. So actually the red one would be correct because 6 times -4 equals -24. That's correct again, but 6x minus 4x is plus 2x. And so that would be correct. There. Okay, let's go ahead and end the Kahoot. Wait, where's the option for that? End Kahoot. All right, third place, Aniket, good job. Second place, Rishi, good job. And first place, Dheeraj. So congratulations, and congrats to our runners up as well. You guys, I think your scores are all pretty close to each other. So hopefully that was good review for factoring. Their homework will be posted in Classroom soon. There's probably some questions that you might not know because we didn't cover it, but that's okay. Just try and do your best. And Aniket, I will see about resending the homework quiz with more time.
Okay, thank you.
Yep.
Bye.
Yeah, so that's all. Thanks for coming and feel free to leave. Stay if you have any questions.
Bye.
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 Bye. Thank you.
Thank you for letting me unmute.
Oh yeah, no problem. I'm glad you
Bye.
unmuted. Yeah.
Bye.
Bye. All right, the two of you left. Do you guys have any questions?